For midpoint rule, you need to find the midpoint for each interval. So 0 to 1, this is the x0, x1, x2. 1 is the 1 quarter, 1 half, that's the 3 quarter. So the first midpoint, the midpoint for first interval will be 1/8. That's this one start. And this one is the 3/8. And 1/8. 7/8. Okay. So the midpoint is be approximate. So delta x will be equal to b minus a/n. So be 1 minus 0 divided by 4. So b delta x is equal to 1 quarter. And I have a plug into 1/8. And this is 3/8, 5/8, and 7 divided by 8. Okay? So that's the 1 quarter over 4, and that's the e to the 1/8 plus e to the 3/8 plus e to the 5/8 plus e to the 7/8. There. And Joe the rule. That's the delta x divided by 2. So I have delta x 1 quarter over 4 divided by 2, which would be 1/8. And I have f0 by 2 multiplied by f of 1 quarter plus 2 multiplied by f of 1 half plus 2 multiplied by f of 3 quarter plus f of 1. So the 1/8, then I have e to 0 to be 1 plus plus 2 times e to the 1 quarter, 2 multiplied by e to the 1 half plus 2 multiplied by e to the 3 quarter plus e plus e. And the last one will be Simpson rule. Simpson rule will be delta x divided by 3. So be 1/12. This is the delta x divided by 3. Okay? And I have f0 plus 4 f1 quarter plus this 2 of f1 half 4 f of 3/4 plus f of 1. So it's equal to 1 divided by 12, and this e plus 4 multiplied by e to the 1/4 plus 2 e to the 1/2 plus 4 multiplied by e to the 3/4 plus e. Okay, that's the answer. I think in the test, in the midterm, this should be relatively easy question to get points. 这应该是比较简单的。We also put the translation for some keyword. I think might be something. I think just put the Chinese translation for all keywords, but whenever I find someone might be interesting for you, I'll put it there. And this is the approximation is noun, and it could be a verb. It means what thoughts. Approximate can be adjective of the verb. Okay. Subinterval 是句子。So I put this vocabulary here. Okay, let's try the error analysis, 误差分析error analysis. Here, error analysis for to approximate the integral from a to b f x dx for both rule. In trapezoidal rule, the absolute value for the error will be no greater than b minus a quantity to the cube to 3 powers divided by 12n squared and multiply maximum of this second derivative, maximum absolute value of second derivative of x. That's the maximum value for this quantity. X between a and b. For Simpson rules, the power become, instead of the 3 power 3 is the power of 5, and the denominator becomes 180 n to 4 power. Okay. And here we force the first derivative, the fourth derivative for the f(x). Okay. And that's pretty simple here. So it should be. Let's try the trapezoidal rule. Okay. So you know E. That's equal to b minus a to to the cube and 12n squared.
10分钟。
So basically, this you get this one, right? So to find analysis here, so what you need to do, you need to find this the derivative. For instance, he's talking about this one. So you need to find the second derivative or first derivative. And phi is the actual value. Then you need to obtain the maximum of this quantity of that quantity for x between a and b. So you need to get this string value, the maximum first. So find the for trapezoidal rule, when you find the second derivative and find the actual value, find the maximum, then solve the equality, and you will find the error product with no n. Okay. And also put the sum translation for those the large like subintervals. L error analysis of the bound inequality such that a partition and so on and so forth. Okay, let's try. Simpson rule will be similar things. Let's just try an example. You'll find that. Okay, want to use the trapezoidal rule to estimate is the integral, is definitely integral from 0 to 1 e to the minus x squared power, which should be dx. It should be at the y, it should be e to the minus x to 1 dx. Okay. For some reason, the b of x was it's cut off by something there. Okay, so I'll find n. Okay, that's the value of this. This question says we need to find n. Estimate is the. So the question is we need to find n. You know, if you divide into, you just partition the 0 to 1 into more intervals, you will get more accurate results. Okay. So I want to find n such that is the trapezoidal rule to estimate this the interval. The error will be less than 0.01. Okay. So find n. So fx is equal to e to the minus x squared need to find the second derivative. The first derivative will be equal to 1. Will be e to the minus x squared multiplied minus 2x. Okay. And second derivative be equal to minus 2 e to the minus x squared and plus minus 2x e to minus squared multiplied minus 2x. So you will have e to the minus squared, then the what? Then let's be the 4x squared plus 2. Improper interval basically involve a few types. One would be you have different limits of integration. Okay, different limits. Or infinite upper limit. Infinite upper limit, for instance, this is the integral. This one have infinite upper limit because it goes to infinity. And over your infinite lower limit, your lower limit go to minus infinity. The other one is the infinite limits. This case, integrate from minus infinity to infinity. So, and that's the one we see the infinite limits or infinite upper limits. That's the first type of improper interval. Well, there's only two types. The first type, you probably have 3 cases. And for the second type of improper interval, which would be infinite discontinuity. What does that mean? Infinite infinite discontinuity. This means 无穷不连续性. What does it mean? For instance, let's see for this one, right? When x is equal to 1, because the denominator cannot be 0, right? Denominator x minus 1, so x cannot be 1. If x equal to 1, the denominator becomes denominator equal to 0. For this case, right, even though it's not from 1 to 3, but here, you integrate from 0 to 2, right, including 1. So both cases that involve x equal to 1. That's when x equal 1 will make this function discontinuous. Okay, so this called this type in infinite discontinuity. So there are two types. One would be your upper limit or lower limit go to infinity or minus infinity. And in their case, would be you have some value. The integral includes some value which make the function discontinuous or go to infinity. They can't. Infinite discontinuity. So for this one, let's try the number 2. And we'll try this one later. This one will do later. Let's try a few examples here. Okay, to this one is the with different upper limits. So basically, we are going to replace the infinity by, we replace the infinity by b. And we let b go to infinity. So 1 over, so this one. Okay, then and here will be natural log of x, also f of x will be 1, 1 to infinity. So become limit b to infinity, and some here should be b in here. So what you get? So b natural log b minus 0. So this will go to infinity. Basically, just replace this is infinite upper limit by b, and the b is equal to infinity. Same thing here, is to be equal to limit and a go to minus infinity, and I replace the upper limit by a to 0. That would be 1 divided by 1. 1 minus 2x to the power of 3 over 2. Okay, that's why I'm going to do the indefinite integral first. So that u equal to minus 2x. So I can write u equal to minus 2 dx. So here 1 minus 2x dx will equal to 1 over minus 2, and there will be u to u. So this will be equal to, that will be what? U to the minus 10. And divide by here of b. Okay. So it's equal to so this will be equal to limit a equal to minus infinity, then I have 1 divided by square root of 1 minus 2x from integrate from 0 a to 0. So you will get what? You will get limit a to go to infinity and 1 minus 2a. So this is equal to 1. Okay. Basically, just replace the upper limit by b. That b equal to infinity. And this one, we replace the lower limit, which is the minus infinity, replace it by a. And that a equal to infinity. And we did this in the different interval, right? Use the method, the substitution method, so that u equal to 1 minus 2x. So you can get is equal to 1 over square root 1 minus 2x. And evaluate at upper limits and lower limits, we will get this limit and it will be equal to 1. I'm going to look at the other one, but I'm not going to do it. Here, that for instance, we integrate from minus infinity to infinity s squared. In this case, right, you need to do it. You need to break it into 2 parts, okay? And in the textbook, if your upper limit is infinity, lower limit is minus infinity, you can just put any constant there, c. So I can break it into, I integrate from minus infinity to c. And c to infinity. You break it, and c can be just any constant. Any constant will work. You can use 1. You can use 1 or 2 or 3 or pi or square root 2 or e, whatever. And the easier choice would be I put 0 here. It will be much easier for most cases. So for this case, right, you need to break down into 2 intervals. only have the upper limit is infinity, or lower limit is minus infinity. And you will get here, remember, we replace the lower limit by a, and then a go to infinity, minus infinity. And here we replace the upper limit by b, then b equal to, let b equal to infinity. And you can do the rest of the work, okay? I'm going to stop here, so you can do it by yourself. Okay, so we have tried the three cases for the improper integral with infinite upper limit or infinite lower limit or infinite limits. Okay? And for last one, let's try the last one. Just let's try this one. Let's try this one.